one of the things we've looked at in addition to breeding and all the other things is pest management with edamame. And as you would expect, it's pretty much the same pest group that you would have on soybeans, but we have noticed a few differences. We've got Kemper Sutton's a student that works in both plant pathology with Steve Rideout, and then the insect part with me, is that because these varieties aren't the same soybeans that we've bred for grain for years in this country, we have bred resistance to some insects or tolerance over the years. Things like Mexican bean beetle. It's not a huge pest to soybean, grain soybean anymore, but man, when we started planting some of these edamame varieties where probably a lot of their Bo, you would know, a lot of that genetics may have came from China. Some things that we haven't seen in a long time in a soybean plant. Mexican bean beetle just went berserk on it, just fed on it like so we're seeing things on feeding on edamame that aren't typical that we're seeing on grain soybeans, but a lot of the same characters, just damaging the plants a lot more. Same thing with disease. We saw a lot of disease. We had a late planted one our first year, and you know, Steve knew what was out there, but he was like, "Holy cow, I haven't seen that in years." And so it's that kind of stuff. We're dealing with genetics that are not the same genetics that we have bred into soybeans for years and years, and because of that, I would say as a whole, edamame is a little more susceptible to pests. And then your product is even more, there's less tolerance for insect injury or disease. Like you can't have a marked up looking produce because you're going to eat it. For instance, like a little stink bug feeding mark on a seed, not a huge deal for grain soybean, but try cracking that open and you got this spot on this seed. You may not even eat that, or you may not even buy that, you know, bird's eye variety anymore because of that. So we're dealing with pest management probably is a little more important. That's the bottom line. A little more important. This is a higher value vegetable crop now, and that's it.
So one of the fun things about this edamame project is it includes food science. So I've had a career for a long time in the Department of Food Science and Technology, and that is not commonly an engagement with a plant breeder. So why am I involved? Why is our crew from food science involved? Because the whole point of growing this vegetable soybean variety is so that people will eat it. And for people to eat it, the Department of Food Science and Technology discusses concepts of how do we process it, what would be the quality standards, what are the sensory qualities that make someone interested in coming back and eating it again, what are the food safety aspects associated with this vegetable. And the same then with our extension to the economics aspects of this product. While that's not part of our immediate department, we do work very closely with the Ag Econ department to try to understand how do these values that people assume associated with this product translate into purchase price. What would be the opportunity for them to want to spend how much of their hard-earned money to make this part of their nutritional, dietary, or pleasure eating. Now I'm going to confess, I'd never tried edamame before I joined this project. But now it's in my freezer with fair amount of repeat purchasing. I'm not getting the free stuff, like when they harvest it and we process it. It doesn't come home and live in my freezer. I have to go out and buy it too, which is really good for creating the market. And someday I'm really looking forward to being able to say, this is the Virginia Tech VT Sweet product that I'm putting in my refrigerator or freezer. And I hope that you all will see that too. Let me ask that hand. How many of you have ever tried vegetable soybeans or edamame before? Look at you, this is great. What a forward-thinking audience we have here. All right. Well, you know, this is again one of our delinquencies is we need to make certain it's part of every barbecue meal we have at every AREC from here on out, so we can start promoting it. So we're talking here in this presentation about why are we involved? And some of what Bo asked us when she's breeding for this product for a Virginia quality, it's what will people want to have in their product? So yes, it's green, that's an edamame feature, but what green is green for the proper selection for the recurring thing. And we do know that certain parts of that green color discoveries are, certain greens are more valuable than other greens. And so we're looking for what's that right color that was going to translate into a higher economic thing. She already mentioned the sweet sensation. So when we think about sweet, most of us are thinking it's sweet as in a candy bar or soda or something like that. But in vegetables, sweet is a relative term. It's not nearly sweet as if you were, true confession, the kid under the table and their mom can't see him, but you're eating out of the sugar bowl. I don't know any kid that did that personally, but I do know it happens. So that's not that kind of sweet. It's one of those of, it's sweeter compared to something else, another vegetable. So edamame is sweeter than lima beans. It's kind of in the same class, but it's a sweeter product. So why would people eat lima beans? Because they grew up with them, but they're not a real high popular vegetable. You don't see those in a lot of places. But you're seeing edamame show up in a wide variety of things. It's coming as a vegetable on your plate. It's on the salad bars at the retail places where you might be going for a salad bar. You're seeing it in the pod as an appetizer at restaurants. This is a lot of places where people are seeing this product. And as Bo pointed out, it's coming in fresh into the farmers markets and other locations too. So people are seeking it now. And you all are a testimony to that, so keep it up. But what's also interesting is salty is a parameter that's also not something you would identify. It's not like it has a layer of sodium on the outside. It's just that by having that little bit of extra salty characteristic, we know from many things in sensory science that when you add a little bit of sodium, salt, to a product, it enhances the sweet perception. So this is a great combination of parameters that are being bred into here to make this ideal flavor that people identify with it still being a very healthy, nutritional delivery. So other things that we're doing is assessing the actual chemistry of those, looking at the sweetness, the varieties of sugars that are showing up, and how those are playing a role in this perception of sweetness. So it's not just a standard sugar molecule of sucrose, but is a combination of a variety of sugars that are known to be in vegetables, and that's an important thing. And so our hope is that rather than having to do a lot of human testing for here on out, is that we'll be able to create some types of analyses that'll predict whether or not this is going to be in the right category of sweetness. And that'll diminish our need to use human subjects for a lot of our sensory testing. And then ultimately, this all comes down to, once we have grown a great variety, you all are propagating those into a number of other places, are we able to create the market for it? And that's where our extension of our project is really needing to go. And that's going to include, how do we convince people to plant and grow this? But secondly, can we harvest it? That's the mechanisms that we're trying to look for, is how to make that most efficient. And then also then to make certain we have the processors ready to buy the product and to put it into the retail consumer hands or the retail market, so that people will be utilizing it and asking for more. So that's where we're at the moment. I also wanted to point out that in the process of doing this, we're not just doing standard protocols for our development of this. There's a lot of what we're calling smart farm technologies. There's a capacity to use innovations such as your UAVs, unmanned aerial vehicles, to do assessments, and I think Joseph's going to talk about that, not in edamame, but on other things. What we're also looking at, what are the digital imagery that are happening, and how do we analyze that to be able to tell us where the emergence of the seeds are coming through, where we're having pest control issues, or weed need to do some weed suppression. How are we also being able to then predict when it's harvest time? And so all of these combinations of technologies are helping us to decide, make good decisions, make more efficient decisions, and be able to save time and money in our potential for making this a viable crop for Virginia.
My name is Keren Brooks, and I am a Ph.D. student under Dr. Mark Ryder, and we kind of moved to the processing side, but let's take a step back into the beginning of the growing season. And something you've probably noticed as a theme, as we're introducing a new crop, we kind of want to compare it to something. in our management strategies. And so the big question the nutrient management team is asking is, do we compare this more to a typical oilseed grain soybean, or do we compare it to a snap bean, where they fertilize and they fertilize with nitrogen and maybe put out 2 applications? And so we created a program where we compared no fertilizer at all, kind of to simulate the oilseed program. And then we also had 4 different rates of nitrogen applied at 2 different timings at planting versus split application. And so what we've seen is that the snap bean management program is is actually under here, Dr. Oh yeah. We've seen that the snap bean management program is more beneficial. We have seen a boost in yield with nitrogen applications. So we did this 2 years on the Eastern Shore, 2019 and 2020. I'm not sure how big these lines are, but you can see that the line is increasing as we increase the fertilizer rate. And so we are seeing a boost in yield. But when we compare at planting versus split application, there's not a whole lot of difference. You can see 2019, it was basically a flat line, whereas in 2020 we did see similar yields to the at planting application. So I'm not gonna recommend 2 applications on the field for this. I think if you put it all out at planting, you'll get similar results based on these results. So an additional, we have a new grad student working on additional nutrients, so looking at phosphorus and potassium. I did 1 treatment with sulfur and we saw some positive things, but again, that's just 1 treatment just to see if it would be beneficial. And in addition, Dr. Ryder talked about 2 different lengths of growing season. So 78 days versus 120 growing days. And so with that, the mindset is, can we shorten that season, give the pests less opportunity to damage the yield and damage the plants that we want to keep pretty, because they're going to be eating the whole seed, and the pod is going to be marketed as well. So that's another piece the nutrient management team is taking on, trying to create a pretty product as well. And then we are sending some of our seeds to the food lab to see if our fertilizer treatments are changing the flavor. And so it's kind of fun. We get to work with every aspect of this Edamame team.